So here we have a problem on average velocity, and the question at hand is, if it takes Bob 9.5 minutes to walk with an average speed, or rather specifically an average velocity of 1.2 meters per second, what will Bob's displacement be? And of course, this takes us to the definition of average velocity. So the average velocity can be thought of as the change in displacement over the change in time. And this looks very reminiscent to our slope formula, where delta x here means x2 minus x1 over delta t. In this case, delta t represents the time elapsed, so you could say t2 minus t1. However, we're going to use the formula in this form. We're going to solve for delta x because they're asking for a displacement. So we can rewrite the formula as delta x is equal to the average velocity, because that's a given number, multiply that by the change in time, so delta t. So we could probably just simplify. First of all, we need to substitute 1.2 meters per second, multiply that by 9.5 minutes. However, if you noticed, the time and the velocity have different units. Here the velocity is given in meters per second, whereas the time given, the elapsed time, is actually in minutes. So we have to do a little conversion, but that's not very difficult. So we can just multiply 1.2 meters per second and then convert 9.5 minutes and multiply by a factor. So here we got 9.5 minutes, and of course we can multiply, use the unit factor of there are 60 seconds for every minute, right? And then we can see that the minutes will cancel out, and then all you have to do is multiply straight over. So 1.2 times 9.5 times 60 gives us exactly, or approximately, 684.0 meters. Or if you want to be different, you can write this in terms of kilometers, which is about 0.684 kilometers or kilometers. Okay, so let's try a slightly different problem in the same venue here. We have, for example, a problem that says during a hard sneeze, right? The eyes might shut for about half a second. The question arises is, how far will you travel if you are traveling at 90 kilometers per hour? So let's see. So we have 0.5 seconds. You shut your eyes, right? Shut your eyes during a sneeze, very hard sneeze. During sneeze, and you're in a car traveling with a velocity of 90 kilometers per hour. So the question is, how far will your car travel during that amount of time? Well, again, we have our average displacement, which is going to be, or the displacement will be equal to the average velocity rather, times the change in time here. However, the time here again, you always have to be careful of the unit. The units are in seconds, whereas the velocity is in kilometers per hour. So we have to do a conversion factor. But it's trivial. So we will start by writing 90 kilometers per hour. 90 kilometers per hour, and we need to change from kilometers to perhaps meters per second, and that's what we normally work in physics. So let's convert this to, let's see, one kilometer is 1,000 meters, and the reason I write it this way is because you know that kilometers will cancel kilometers, so it's top to bottom cancellation method. And then I have hours here. I want to cancel hours, so 1 hour is approximately, no, not approximately, but exactly equal to 3,600 seconds. And if you multiply all this out together, this would, let's see, this would give us 90,000 divided by 3,600. So this was 90 times 1,000 over 3,600. Okay, but then we still have to multiply times the average. That is the average velocity, but multiply by the time, which was exactly 0.5 seconds. So this is in seconds here, times 0.5 seconds, and all together would give us something like 12.5 meters. Imagine this is only half a second that you close your eyes during the sneeze. The point is, people often use their cell phones to do texting, and they take your eyes away from the road for more than half a second, many times more like 5 seconds, and in that time a lot of bad things can happen. Okay, so here one more problem that we have time for. You have a car. The car travels up a hill. So let me draw a little picture of a hill. You got a hill. Okay. And it travels up the hill uphill at 40 kilometers per hour. Say 40 kilometers per hour, and returns at 60 kilometers per hour. Returns at 60 kilometers per hour, and this is all at a constant speed. Both of these are constant speed. The question is, calculate the average speed. So let me write the question here. Calculate the average speed. I could be typing this, but I like to write it. Calculate the average speed for the entire trip, or for round trip. Calculate the average speed for round trip. Well, as you know, the average velocity is really the total distance divided by the total time. Okay, and notice that we're not given any time specifically. However, we do know that distance is equal to the rate multiplied by the time. So what we can do is we could write the time it takes to go up as d1 or d. These d's are terrible. Divided by the velocity v1, okay, or the average velocity 1, the average speed rather, and the t2, I'm going to use a smaller d instead. The return trip would be t2 equals d over v2. So if you think about it, the average speed, I'm going to change it to the letter S here for average speed, will be equal to the total distance. Now, of course, you go up 1, that's d, and then you come back down, that's the same distance, so that's another d, and then the total time would be t1 plus t2, right? So total time, total time equals t1 plus t2. So if I write that as t1 plus t2 here, then I can rewrite as 2d divided by, now t1 here would be d over the first speed, which was 40, 1 over 40, d over 40, like so. And the next one would be d over 6, I believe it was 60, like so. And as you can see, that these will cancel out, and you end up with 2 over 1 over 40 plus 1 over 60. And when you rearrange this, it turns out that you end up with, let me make some space right over here, you end up with 2 times 40 times 60 divided by, if you, let me see, divided by 40 plus 60, 40 yes, 40 plus 60. Make sure we don't make mistakes here. And then when you multiply all this out, it ends out to be 4,800 divided by 100, which comes out to be approximately 48 kilometers per hour. Question's a little tricky. However, you really must understand the definition of what the average speed versus the average velocity is. So although they are similar, they can be a little bit different and a little bit tricky. Hope that helps.